Hi everybody, this is Mr. Short. Today we're going to be talking about atomic structure, and in particular you can take a look at the three objectives that we're going to cover in today's lesson. Mainly this has to do with subatomic particles, like where you find them, what charge they are, and then also definitions for terms atoms, ions, and isotopes, and how those ions are formed. If we have a little understanding of how ions are formed, it's going to help us to understand how many electrons are inside an ion. Before we get started, make sure that you guys have your periodic table handy. I'm going to go through and show you how to find that. In Canvas, if you click on Modules, it's going to be the second link up top in Unit 1 Atomic Structure, so it's right here. The reason this is important is because if we take a look at our periodic table, this whole number that's up here on top of the element symbol tells us what's called the atomic number, which is the number of protons inside the nucleus for that particular element. So for example, all boron atoms will have 5 protons, just like all carbon atoms will have 6 protons. Okay, so let's take a look back at the notes. We're going to split this into 2 lessons. I'm going to do page 1 here in one screencast, and I'll do page 2 in a second screencast. Okay, also you can see that the writing that I do up here is going to be in red so that you can follow along easily. We're going to start out with definitions for the terms atoms, ions, and isotopes because people often use those interchangeably, but they actually mean very different things. So atoms have an equal number of protons and electrons, and for that reason, they have no charge. Okay, so equal numbers of positively charged particles and negatively charged particles, protons and electrons. Therefore, they've got no charge. For example, if we take a look at the element potassium, potassium from our periodic table is element number 19. So we know that potassium is going to have 19 protons. And because this is neutral, it must have 19 electrons also. Okay, so 19 positively charged particles and also 19 negatively charged particles as well. For chlorine, if we take a look at chlorine, chlorine is element number 17, which means that it's got 17 protons inside its nucleus. Since it's in its neutral state here, it must have 17 protons and 17 electrons according to our definition of the term atom. Ions, in contrast, they have a charge, and the way that ions are formed is by a gain or loss of electrons, never protons. So they're going to gain or lose the negatively charged particle, the electron, never the positively charged particle, the proton. If you take a look here, we've got the same example of potassium, only now it's got this charge. See how it's got a +1 charge? So whereas neutral potassium atom had 19 protons and 19 electrons, potassium ion is going to have still 19 protons, but the way that it got its positive charge here is by losing a single negatively charged electron. So it must have 18 electrons. Okay, likewise, chloride ion, if it were neutral chlorine, it would have 17 positives and 17 negatives, but chloride ion is still going to have 17 protons, but now it's going to have 18 negatively charged electrons. So one thing that I think you're going to spot when you're thinking about ions and the number of electrons in ions is that you've got to take a look at the charge right up here, and it looks like it gained something. It did. It gained a positive charge, but it did that by losing a negatively charged electron. So you're going to have to train yourself to think backwards about these. Okay, so we've talked about the definition of atom, ion. Now we talk about isotopes. So isotopes are different nuclear forms of the same element. And remember, the Rutherford-Goldfoyle experiment, in that experiment, Rutherford determined that the nucleus is where the vast majority of the mass of an atom is found. Inside the nucleus, today we know that the nucleus has the positively charged protons and positively charged protons and neutral neutrons. So since they're different nuclear forms, isotopes of the same element, they have the same number of protons, but they have different numbers of neutrons. And we've got a couple of good examples down right here with a nice picture. So these are 3 different forms of hydrogen. The reason that each one is hydrogen is because if you look at the key, it tells us that the open circle is a proton. You can see there's 1 proton, 1 proton, and 1 proton inside the nucleus. But then we have different numbers of neutrons. The neutrons are gray. 0 neutrons, 1 neutron, and 2 neutrons. So again, same number of protons, but different numbers of neutrons, making them all hydrogen isotopes. And I know I mentioned at the beginning of this when we were looking at the periodic table that elements are defined by their number of protons. So again, the reason that each one of these is going to be a hydrogen isotope is because each one of these has 1 proton inside its nucleus, and hydrogen is the element that has 1 proton. So when we're asking the question, what element is it? All we need to do is to take a look at the proton number. Okay, now we're going to take a look at the mass, charge, and location of protons, neutrons, and electrons. In terms of charge, you guys all know that the protons have the positive charge. Whoop. Okay. Protons have the positive charge. That's what I'm trying to do here. Neutrons are neutral, or you can say that they have no charge. And the electrons are negatively charged. In terms of mass, the way that we measure the mass of these really small things, like protons, neutrons, and electrons, and even atoms themselves, is on a scale called atomic mass units. And it turns out that the mass of a proton is 1 atomic mass unit. Now, just like the mass of a proton is 1 atomic mass unit, the mass of a neutron is equal to that. It's also equal to 1 atomic mass unit. Electrons, though, are really, really small. And because they're so small, we typically don't consider the mass of an electron when we're thinking about the mass of an atom, ion, or isotope. The mass of an electron is roughly 1/2000 atomic mass units. That's a very rough number. To put that into perspective, it means that you would need 2,000 teeny tiny electrons to equal the mass of either 1 neutron or of 1 electron. To put that into perspective also, if you were to take out your calculator and type 1 divided by 2,000, what you would get is the number 0.0005 atomic mass units. So either way you look at it, their mass is very, very small, and for that reason, we don't typically think about and consider the mass of electrons. Location, again, we know from the Rutherford experiment that the protons and the neutrons are located inside the nucleus. And actually, I would add a little star to that. The Rutherford experiment only told us that the protons are found in the nucleus. We hadn't identified neutrons yet at that point. It was only until later on in about 1932 when Chadwick discovered the neutron. All right, for electrons, what we're going to say is electrons are outside the nucleus. And in section 1.2, the next section, what we're going to do is to better describe where the electrons are at and what the electrons are doing. Okay, just to drill home a couple of points right here. I think we've addressed these questions before, but I want to make sure we understand these. Question number 1 is, what is the charge on a nucleus? So just like Rutherford determined, the nucleus is positively charged because the only charged particle is found inside the nucleus. It's the only charged particle found inside the nucleus. Okay, so again, it's positively charged because the only charged particle in the nucleus is the proton. Okay, so the nucleus has a positive charge. Last question, where is most of the mass of the atom found? Well, if you take a look up here, we know that the protons and the neutrons are inside the nucleus, and we say that these are the 2 massive subatomic particles. So, most of the mass of the atom is in the nucleus, because this is where the two massive subatomic particles are found. And in particular, we're talking about the protons and the neutrons. Okay, thank you very much. We're going to stop right here and we'll come back with a follow-up video in just a minute.